In Mexico, each year, millions of cubic meters of wastewater are discharged in big bodies of water, which are the main sources of clean water available in the country. This wastewater usually comes from the municipal, industrial, and agricultural sectors, and it is a problem because it is not being properly treated or it has no treatment at all.
According to an analysis made in 2018 by the CONAGUA, 70% of the water in Mexico, including lakes, lagoons, and aquifers, are nowadays polluted. Water pollution has a severe impact not only on ecosystems, but also in the Mexican population's health.
The mismanagement of municipal, industrial, and agricultural wastewater involves that the water consumed by millions of people become dangerously polluted. Unfortunately, this exposes the Mexican population to high health risks and diseases.
The general objective of our project is to generate a new species of microalgae capable of extracting and retaining organic matter that pollutes the different water samples taken from Xochimilco's water.
The reason we create this project is because nowadays the need for clean and potable water and the sanitation is imminent. Therefore, we decided to create a quick and effective solution to reduce the problem of organic matter that pollutes the Mexican water bodies.
The microalgae we are presenting is an eco-friendly and cheap solution for solving the problem. Also, we came up with the idea of this algae because we discovered that at the end, this could be a solution for water pollution and also have two extra byproducts: food for cattle and fertilizer.
For instance, the first method to achieve this is create a reverse phase HPLC, which is a type of improved chromatography regarding wastewater in Xochimilco's lake in order to identify its chemical and organic contaminants. It will make it easier for us to select what parts are needed to be reduced in order for it to be potable again. Several samples at different times are going to be required in order to get the most precise information. Therefore, each week for 2 months, HPLC is going to be made in different piers of Xochimilco because of its high contaminant concentration and a 500-meter around.
The second method of our project is research about the algae Edogoniaceae to know its biological characteristics, scientific classification, and its type of reproduction. Then, apply the evolutionary pressure at a 10% in a random selection of 100 samples of algae in order to start monitoring its growth in a high mean of oils and fats. This will last from 3 to 4 weeks. Then, observe the evolution of the algae in the previous mean and select the best 10 samples, considering their growth and levels of nitrogen extracted. And finally, take the 10 best samples and change them into a high mean of amino acids and carbohydrates to measure again how much they grew and the amount of nitrogen they were able to capture.
The third method is to choose the 10 algae samples which are the best absorbing the organic material. Sediment the previous 10 samples in a centrate rich in minerals. Afterwards, test the water purification by the activated sludge, which is one of the best microalgae cultivation media. In order to perform the HPLC, there will be selected 10 water samples out of the 100 that were collected from the 5 most polluted spaces. By HPLC, a chromatography is done. The study depends on the affinity of the molecules with states of matter. The more solid they are, the more they take to pass through the chromatography column.
And finally, our fourth method is research the possible use of our algae as food for cattle and fertilizer. As food, the algae must include at least 36% of minerals, such as potassium, calcium, phosphorus, magnesium, and sodium, 32% of fiber, 20% of protein, less than 3% of lipids, and vitamin C, B2, and B3.
On the other hand, test the results of the application of the fertilizer on tomato crops by measuring the plant growth, the size, and the amount of tomatoes. Also, comparing it to other common fertilizers such as manure. Once established if the cattle can eat the algae or that the fertilizer can be used without damaging the crops by killing or raising a disease on the plants, we can start producing this with the exceeding algae.
This is a small but assertive step to achieve sustainable water usage.